Okay, let's talk about how to pump this system down. We did it the other night in class once, but let's just refresh our memory on how to do it. Why would we want to pump the system down? First of all, pumping the system down, you'll hear different guys call it different things. That's what I call it. Pumping it down, meaning we're going to trap all the refrigerant in this system, or as much as we can anyway, into this condenser to store it while we do work on this side of the system. So if we have a dirty evaporator coil that we have to pull out to clean, or we got to change the evaporator coil, we have a leak somewhere that we got to do welding on, we got to change our metering device, a multitude of repairs that we can make on this side of the system where we need to get rid of the refrigerant. Instead of taking it all out of the system, we can pump the system down and store it in this condenser. Make our job a little easier. Okay? So the first thing we're going to do is we're going to come down near to our service valves, and I've already taken the caps off, but these are going to be right on the top. Just take those off. We're going to close the liquid line first, because remember, the liquid line is leaving the condenser heading to the evaporator. But we're trying to trap the refrigerant in this condenser. So I don't want the refrigerant leaving this condenser. I don't want it leaving here. So I'm gonna shut this down so we stop sending it to the evaporator. That's gonna be our first step. The next thing that we're gonna see is we're gonna start to see this condensing pressure start to drop. Well, why is it going to drop? We still have all the refrigerant in there. Well, that's because where we're tapped in here on our pressure is actually measuring this side of the system. So when I close this valve and trap the refrigerant on this side, this pressure is going to start to head towards zero because I no longer have pressure in this line. It's starting to this line is starting to empty out, meaning my pressure is going to start going down. And I'm taking my pressure on this side of the system. So when I close this valve, I'm going to stop getting pressure on this side, because we're not allowing refrigerant to travel through anymore. So you're going to start to see this pressure drop. You're also going to start to see this pressure drop, because as I'm not giving any more refrigerant to the evaporator, the pressure in the evaporator is going to start to drop. And we're going to use the compressor to suck all the vapor that's left on this side of the system into there. So as this starts to get to zero, and this starts to get to close to zero, I'm going to close this one. Meaning most of my refrigerant at that point is going to be trapped on this side of the valves. Now the other thing we got to take into account is I'm doing this on a heat pump. It doesn't have to be a heat pump, but there's a low pressure safety switch in here. Meaning when the pressure gets too low, we don't want the compressor running at low pressure conditions. Just like we don't want it running at high pressure conditions. So when this thing gets too low, there's a switch in there that's wired in series with the contactor, the 24 volt contactor power. That switch will open and the contactor will open, thus cutting power to the compressor. Well, that's not going to work for us when we're trying to pump this thing down. We need that compressor to keep running. So there's a couple things you can do. First one, and probably the most safest thing, is you just create a jumper from your yellow wire, your compressor control 24 volt wire, and jump it straight to the contactor. That will keep power going to that contactor. And when you're done and you get both valves shut, then you hit the disconnect. Shoot this one over here. and kill the power. The other way you can do it, that contactor has a plunger. And I can just take something like this. I'm just going to use my wooden little brush here. And as I start getting low, I'm just going to put it on there and keep that plunger depressed until I'm ready. So let's see what happens. All right. Okay, so I'm going to start closing this liquid line. And we're going to start to see these pressures drop. Now, as soon as I get this liquid line closed, I want to move right over to the vapor line and start closing that one as well, because you're going to see these things take a long time to get all the way to the bottom and close them up. As you can see, it takes a little bit, so we want to get the vapor line started as soon as we get this one closed. So we're ready to go. Okay, well, I'm at the bottom there. Now our liquid line is closed. We're going to start to see the pressures drop. And I'm already going to start on the vapor line. Now I know this thing's going to cut out on low pressure, so I'm going to hold the plunger. And I'm not going to allow that contactor to come out. And I'm still working on the vapor line just to get her down. Probably getting pretty close. We're going to hear the compressor making all kinds of weird noise. That's okay. We don't want to do this a whole lot, but that compressor is going to be able to handle it for a little bit. I'm going to keep going. We're still dropping just a little bit. And that's probably be as close as I can get. So I'm going to close her down as far as the bottom. There I'm at the bottom. Now I'm going to hit the disconnect. And we're pumped down. Okay, now we're all pumped down. I still got my valves closed. Disconnects off. Always make sure, we don't want that compressor turning on in a pump down condition. Okay, that's pretty, I mean, there's not much I can say about that. We don't want that compressor coming on. So as soon as we're done pumping her down, hit the disconnect, power off. Okay. I always like to, as well, if for some reason I had to leave this overnight, which you try not to, if you're going to leave it if you're going to do this, try to get your job that day, done that day. If you have to leave it overnight though, for whatever reason, you know, leave the disconnect off, lock it out, you know, the lockout, tag out procedure that we learned. But the other thing I always like to do is I always like to unplug the 24 volt power from my contactor as well. Now that low pressure switch is going to be open in there, just because we have a low pressure condition right now. But I don't want to take any chances with the customer coming through and, you know, thinking that they can flip up on that lever and their cooling's going to come on, that I was all done. You know, we want to make sure we're communicating with the customer. But just to cover your base, disconnect off, lock it out, and I always like to pull off the 24 volts on the contactor, wrap a little piece of electrical tape around that so it doesn't ground out inside here for whatever reason. That way, no high voltage, and there's no way that you can get a low voltage signal to that contactor. We don't want that compressor coming on if we gotta leave it. Okay, but now what we've done is we have all our refrigerant, or most of it anyway, trapped in that condenser. And remember, I'm reading low pressures because my pressure taps on my valves are reading this side of the line, the side that's empty. The refrigerant's trapped on the other side. Now I can come over here to my evaporator or my line set, whatever I need to do, whatever work I need to do, I can now open that system. As we see, there's a little bit of pressure left in here. But I'm willing to bet it's probably just vapor. And we'll just check right here. And as you can see, there's not much pressure left in there at all. Not much at all. So I'd probably, if I'm gonna open that system up, I'd probably wanna bleed it off right here at the hoses, you know, but there's not much pressure left in that system at all. I'm ready to go ahead and open this side up and go to work. Now when I'm all done, and we're gonna learn this next week, when I'm done opening the system, remember, when we open the system to the atmosphere, moisture equals bad inside of a refrigeration system. And when we open it to the atmosphere, we're allowing moisture in. So when we get all done, we close this all up. First thing we're gonna do is we're gonna pump it full of nitrogen, this side anyway, because remember our refrigerant's trapped on this side. We didn't open that side of the atmosphere. But we're gonna pump this side full of nitrogen and leak test it to make sure there's no leaks. Our welds are holding, or our where we put our metering device back in. You know, we got our nuts down. We got enough torque on there to hold it in. We're gonna leak test it. That's when we're done leak testing it, then we're gonna pull a vacuum on it. We're gonna pull all the non-condensables, all the moisture out of there. We're gonna pull the pressure down so far on that thing, 500 microns, that any moisture in there is gonna boil off and get sucked right out of there. Then once that's all done, we're happy with our vacuum. We passed our leak test. We're good to go. And I'm gonna come right back on down here. Now I'm ready to let the refrigerant back in the system. Doesn't really matter which one you open first. I always like to start one, get it a little bit, and then come over and do the other one, and then finish them both off. But we're just gonna open them up. And you can kind of hear the pressure rushing back in. I'm just gonna kind of move over here. Do the same thing. You just heard the click. That means my high pressure or my low pressure switch just closed because we got enough pressure in there. The low pressure switch closed. The contactor went back in because we're still calling for cooling on the thermostat. So as soon as we got that pressure back up to where it was that low pressure switch was comfortable, it closed again and we passed power back to the contactor. But I have the disconnect off. I don't want that power coming on just yet. I want to make sure I get all these valves open. When you get to the top, you don't want to wrench it over as tight as you can. You don't want to be so stressful on the valves. I always like to get it to where it stops and then kind of back it off just slightly. I'll finish and open this one. We're at the top. Back it up just a little bit. We're good. Now we're open. Those are pressures. And we're off and running. Now remember, a lot of the times, depending on how long your line set is, things like that, we might not have enough capacity to hold it all in that condenser, all the refrigerant. So we definitely want to make sure if we lost some refrigerant doing this process, I'm going to check superheat and subcooling to make sure we got enough refrigerant back in that system. And if we don't, then I'm going to add some back in.